Welcome to Study Loop.
For a particle in a box, we are asked to find the degeneracy, the number of different quantum states that give the following energies. So the corresponding energy state of a three quantum number system is given as the following. So the energy is equal to h bar squared times pi squared divided by 2 times the mass times the length of the box, L squared. And then this is multiplied by nx squared plus ny squared plus nz squared, where nx, ny, and nz are the three different allowed quantum numbers. Of course, these numbers are integers, so they can only take on a number like 0, 1, 2, 3, something like that. And they have to be a positive integer, so 1 and above. So for the first one, we're told that nx squared plus ny squared plus nz squared has to equal 3. Well, the only way that this can be true is if nx, ny, and nz all equal 1. And you can try this. So again, nx, ny, z all have to be a positive integer greater than 0, so 1, 2, 3, or 4. If you plug 1 in for all of them, 1 squared plus 1 squared plus 1 squared gives you 3. So that's where that number 3 out front comes from. If you plug in another number but one of them, so try to do 1 squared plus 1 squared plus 2 squared, and you're going to get larger than 3. So 1, 1, and 1 are the only positives, so the degeneracy is equal to 1. There's only one possible quantum state, and that's nx, ny, and z is equal to 1. For the next one, we have a number of 9. So nx plus ny, nx squared plus ny squared plus nz squared can equal 9. Well, the only way this can be true is if 2 of them equal 2 and 1 of them equal 1, because 2 squared plus 2 squared is 8, plus 1 squared is 9. If you plugged in any other numbers except for that, for instance, if you gave one of them a value of 3, then all the other values would have to be 0, and that's not possible. So the only way this is possible is if 2 of them are 2 and 1 of them are 1. But there's different ways of doing this. So we get an x, ny, and that kind of looks like a y. There we go. And z. Again, different quantum numbers. So one of the ways to do it to where the square of all these values add up to 9 is if it's 1, right? So nx is 2, ny is 2, and nz is 1. You square those values, and now you're going to get 9. So that's one of the possible states. Another one is 1, 2, right? So if 1 is 2, if nx is 2, it is 1, and nz is 2, this also adds to 9. And the last possible rotation of these quantum numbers is 1, 2, and 2. So nx is 1, n is 2, and z is 2. So there are 3 combinations of nx, ny, and nz to get us to a number of 9. So the degeneracy state is 3, because there's possible combinations.